शांति चारों ओर, होगी शांति चारों ओर, होगी शांति चारों ओर एक दिन। वो मन में है विश्वास, पूरा है विश्वास, होगी शांति चारों ओर एक दिन।
Dear students, you will be giving most important exam of your school life from 21st April 2021 onwards. Due to corona pandemic, this academic year was challenging for you all in terms of offline teaching learning process. In spite of that, students, you all have studied well with full passion and confidence and are able to complete your portion. I really appreciate your hard work. Still, we feel some students are not assured or confident whether they have completed the studies or no. In order to help such students, a Seam Gyan channel have started a series providing helping hand. In these series, we are going to solve all your queries related to Science 1 and 2 and make you feel confident by solving all your queries and by clearing all your doubts. Let us start with our session today, SSC at one glance, a complete guidance series. Concept, Direction and Coordination by Mr. B. Jadhav. Myself, Mr. Santosh J. Singh. Technical Guidance, Mrs. Megha M. Rane. Today, we are doing Science-1, Chapter-3, Chemical Reactions and Equations. Before starting with the actual chapter, let us understand SSC Science 1 and 2 paper pattern. Dear children, question number 1A of your paper is MCQ based question which is coming from textbook only. 1 mark each and there will be 5 questions. So it is for 5 marks. You are expected to write the correct option and the answer for these questions. Question number 1B is again an objective type question where you will find question like complete the statement, true or false. No fill in the blank will be asked. So again, 1 mark each question. This is for 5 marks. Question number 2A is give reasons, any 2 out of 3. Question 2B is write in short, any 3 out of 5. This is for 6 mark, 3 question. Here, some numericals, laws, principles, properties give difference between such type of questions can be asked. Question number 3 is answer the following any 5 out of 8. Here each question is for 3 marks, so the total question number 3 is for 15 marks. Here the question like complete the table or chart, explain with the help of diagram, explain the law, explain the theory, such type of questions can be asked. Question number 4, answer any 1 out of 2. This question is for 5 marks. Here conceptual diagram based question, complete the table, answer in detail, or maybe a paragraph will be given to you out of which 5 1 mark questions will be asked. Such type of questions are there in question number 4. You have to complete this 40 mark paper in 2 hours. So let us understand about the time management. Children, you can give first 10 minutes to read the paper carefully. The next 20 minutes can be given to complete the question number 1. Next 30-minute time can be utilized in completing the question 2. Question number 3, as it is a lengthy question where you have to answer 5 questions in detail, you can give 40 minutes to this question. Main question number 4 can be given 10 minutes. And still at the end you have 10 minutes to revise your paper. That completes your 2 hours. Let us start with our today's session by understanding some basic concepts. Students, one thing you have to understand that chemistry is full of chemical reactions. So a child who is very good at writing chemical reaction and chemical formulae will definitely excel in the subject chemistry. You have already studied valency chart in your grade 9. Using that valency chart and some rules, today we will first understand the rules for writing a chemical formula, and then we will proceed with the chapter. Let us start. The first rule is positive first. In a chemical formula like sodium chloride, sodium forms a positive ion and chloride forms a negative ion. So sodium is always taken first and chloride after that. The second rule is exchange valency in simplest ratio and ignore writing 1. Let's take an example of sodium chloride once again. The valency of sodium is +1 and chloride is -1. 1:1 is already a simplest ratio, so we can just exchange the valencies. We will get sodium 1, Cl1, but remember, we ignore writing 1. We don't have to actually write 1. Even if we don't write anything, it is understood that it is 1. So sodium chloride gets the formula NaCl. Let's take a few more example. Aluminium oxide, it is also called alumina. The formula is Al2O3. Let us understand how it is Al2O3. Children, aluminium has a valency 3 plus and oxygen 2 minus. 3:2 is already a ratio which is in the simplest form. So what is the next step? We can exchange the valency to get the chemical formula. So 2 will go with aluminium and 3 will go with oxygen, and hence we get Al2O3 as aluminium oxide. Sometimes a compound like calcium oxide, where both calcium and oxygen have valency 2 plus and 2 minus respectively. So 2:2 is not a simplest ratio. We can reduce it and make it 1:1. And once we get the ratio in the simplest form, we repeat the process of exchanging the valency and ignore writing 1. So calcium oxide has a formula CaO. The next rule is using bracket. Appropriate use of bracket. Sometimes bracket is important, sometimes it is not. We need to understand both the cases. Let us start. When a number is transferred on a group, or we can say polyatomic ion, then it is necessary to use brackets. Example, calcium hydroxide. It consists of calcium and hydroxide. When we look at hydroxide, it is made up of two different atoms, oxygen and hydrogen. Looking at the valency, the simplest ratio is 2:1. So while exchanging, 2 has to go with hydroxide. When 2 goes with hydroxide, it goes to both oxygen as well as hydrogen. So it is very much necessary to use a bracket in this case. So the correct formula will be CaOH twice. Let's see the other example, calcium chloride. Over here, calcium has a valency 2 plus, chloride 1 minus. Ratio is already in the simplest form, 2:1. Now this 2 has to go to chlorine. Now chlorine is not a group, chloride ion is not a group, it is a single thing. So there is no need to use bracket over here. So understand when to use bracket and when not to use bracket. These are few compounds whose formula you can practice by referring the valency chart. You can pause the video whenever required. I will be displaying the answer slide in a moment. Let's see the answer slide. You can verify your answers over here. Once you have got the correct answer for all these compounds, you can now easily start with our chapter, Chemical Reactions and Equations. Chemical change. The following change take place during a chemical change or a chemical reaction. Change in state, change in color, change in temperature, or evolution of gas. So whenever a chemical change takes place, we observe these things. Not necessarily everything will happen in the same chemical change. Every chemical change can be represented by a balanced chemical equation. So let us now understand balancing a chemical equation. Let's take an example of chemical equation. Ferric chloride reacts with sodium hydroxide to give ferric hydroxide and sodium chloride. Over here, the left side is called the reactant side and the right side is called the product side. In order to balance these reactions, we make a table for LHS and RHS. We list the different types of elements present on the LHS and of each element in the LHS. Same thing, we do it for the right hand side. Now, if you look at this table, you will clearly understand that the number of atoms of all the elements are not same on both sides. For example, we can see iron is same 1 on both sides, but chlorine is not balanced on both the sides. Sodium is balanced on both the sides, but oxygen and hydrogen are not balanced on both sides. It means the number of atoms are different. Balancing a chemical equation means to make these numbers same. Number of atom of a particular element on the left side should be equal to the number of atom of that particular element on the right side. In order to balance it, we can use numbers just before the molecular formula. These are the four places where, if necessary, we can use numbers. So I'm starting to balance this equation, and I'm starting with ferric hydroxide. Over here, I see on the right side, there are three oxygen atoms and three hydrogen atoms. On the left side, they are only one. In order to make three oxygen and three hydrogen on the left side, what we can do is we can add three before the sodium hydroxide in the LHS. Now, once again, let us make the table and check. We can see that iron is balanced, chlorine is not balanced, sodium is not balanced, oxygen is balanced, and hydrogen is balanced. Now we need to balance sodium and chlorine. On the left side, we have three atoms of sodium and chlorine. On the right side, we have only one atom each of sodium and chlorine. So what we can do in this case, on the right side, if I add 3 before NaCl, I think that it will get balanced. Now on writing 3 before NaCl on the RHS, let's make the table and check. Now we can see that the number of atom of each element on the left side is equal to the number of atom of that element on the right side. We can say that this chemical equation is balanced. Let us start with the next topic, types of chemical reactions. The first type of chemical reaction is combination reaction. It is a reaction in which two or more reactants combine to give a single product. Generally, I can say that A plus B combines to give AB. Specifically, let's take an example of this reaction where magnesium combines with oxygen to form magnesium oxide. Or we can say calcium oxide reacts with water to give calcium hydroxide and heat. Combination reactions are generally exothermic in nature. Exothermic in the sense they give out energy. Next type of reaction is decomposition reaction, where a single reactant breaks down to form two or more products. It is called decomposition reaction. In general, you can say that a compound AB breaks down into A plus B. Specifically, let's take a few examples. Hydrogen peroxide decomposes to give water and oxygen. The next example is when calcium carbonate decomposes in presence of heat, it gives calcium oxide and carbon dioxide. Decomposition reactions are generally endothermic in nature, the reactions which take energy to proceed. Next type of reaction is displacement reaction. When a more reactive element displaces an element with less reactivity from its compound, the reaction is called displacement reaction. For example, A, which is more reactive, reacts with BC. In BC, B is less reactive. So A will displace B. It will form AC plus B. So you can clearly see A has taken the place of B and formed AC, and B is removed out. Specifically, when copper sulfate reacts with zinc, zinc is more reactive than copper, so it displaces copper from copper sulfate and it forms zinc sulfate, and copper is set free. Before reaction, a blue colored copper sulfate solution and we can see a zinc strip, but after the reaction, you can see the blue color of copper sulfate has disappeared. This is due to formation of zinc sulfate, and we can clearly see the deposition of copper on the zinc strip. Displacement reactions are generally exothermic in nature. You can see that over here. In order to understand which element is more reactive or which element can replace which element, scientists have developed a metal activity series. In this series, elements are arranged in the decreasing order of their reactivity. We can clearly see that zinc is above copper, so zinc is more reactive than copper, and that is the reason zinc is able to displace copper. This activity series helps us to identify whether the displacement reaction will take place or not. The fourth type of chemical reaction is double displacement reaction. It is a reaction in which ions in the reactants are exchanged to form precipitate. Example, AB plus CD. Now A combines with D and C combines with B. We get AD plus CB. Such reactions are called double displacement reactions. Specifically, we can take example of potassium chromate reacts with barium sulfate. It gives potassium sulfate and barium chromate. Here barium chromate formed is solid and a precipitate. We can clearly see the precipitate formation over here. This precipitate is of barium chromate. Endothermic and exothermic process. The process which take up energy are endothermic and the processes that give out energy are exothermic. Same goes for reaction. If we look at this reaction is taking place by absorbing heat energy. So this reaction can be called endothermic reaction, whereas this reaction in which heat energy is evolved can be called as exothermic reaction. Factors affecting rate of chemical reaction. Rate means the speed of chemical reaction. Nature of reactant. If the reactants are very reactive, the reaction will be fast or the rate of reaction will be high. Size of particle. If the particle size is small, the rate of reaction is high. Concentration. Higher the concentration, faster is the chemical reaction. Temperature. Higher the temperature, faster is the rate of reaction. Catalyst. Now, catalyst is a chemical substance which changes the rate of chemical reaction without taking part in the chemical reaction. So sometimes we use catalyst to speed up the rate of reaction. Oxidation and reduction reaction. Let us understand them one by one. Oxidation reaction is a reaction in which addition of oxygen, removal of hydrogen, or loss of electron takes place. You can see the addition of oxygen, removal of hydrogen, and loss of electron in these three examples. Whereas reduction reaction is a reaction in which opposite happens, like addition of hydrogen, removal of oxygen, and gain of electron takes place. A few examples of reduction reactions are given over here. We can clearly see the addition of hydrogen and gain of electron in this reaction. Difference between oxidation and reduction reaction is given over here. You can pause the video and take a note. Redox reaction. Sometimes in a reaction, oxidation and reduction take place simultaneously. Such reactions are called redox reaction. Red for reduction, ox for oxidation. So they are called redox reaction. Let us take an example of such reaction. In this reaction, copper oxide reacts with hydrogen to give copper and water. In this reaction, if we notice, copper oxide has lost its oxygen to form copper. This process is reduction. Whereas hydrogen has gained oxygen to form water. This process is called oxidation. As they are occurring simultaneously in this reaction, the complete reaction is called redox reaction. One more thing, the substance that gets reduced or the substance whose reduction takes place is actually an oxidizing agent or called as oxidant. And the substance whose oxidation takes place is a reducing agent or reductant. Remember this. Next is corrosion. Look at this image. What do you think? We can clearly see that the surface of metal is getting deteriorated or decaying. This is due to the action of atmosphere or environment on it. Corrosion is a process of decay or deterioration of metal as a result of chemical reaction between it and the surrounding environment. Metals are attacked by substances like air, moisture, and acids. Rancidity. Rancidity is a condition in which the substance with oil and fat get oxidized when they are exposed to air. Due to this, their smell and taste and color changes. With this, we end up with the theory of this chapter. We have covered all the important points in this chapter. Now let us move ahead to solve previous year board questions. The reaction of iron nail with copper sulfate solution is dash reaction. This was asked in year 2019 for 1 mark. We know that iron nail contains iron which is more reactive than copper. So iron can displace copper. Hence the answer to this is C, displacement reaction. Here is the next question. Study the following chemical reaction and answer the question given below. Silver nitrate reacts with sodium chloride to give silver chloride precipitate and sodium nitrate aqueous solution. Identify and write the type of chemical reaction. We can see that the reactants are exchanging their ions. So such kind of reaction is called double displacement reaction. The definition of double displacement reaction, and the reactants over here are silver nitrate and sodium chloride, whereas the product are silver chloride and sodium nitrate. We are done with the important points of the chapter. We have also discussed the board question of last year. Now this is a quiz time. Let's revise this entire thing with the help of a quiz. Valency of aluminium and Al2O3 is. We know that this has been formed by exchanging the numbers. So 3 should be with aluminium. So valency of aluminium is 3. The reaction in which energy is absorbed. It is endothermic reaction. Complete the following definition. The reaction in which dash and dash take place simultaneously is called redox reaction. In a redox reaction, oxidation and reduction take place simultaneously. Addition of dash is oxidation. Obviously, it is oxygen. Identify the process from the picture given below. What is this process? We can see that the surface of metal is deteriorating, and this process is corrosion. Let's have a few more questions. Balance the following chemical equation without making tables. Mg plus O2 gives MgO. Over here, we can see that 2 atoms of oxygen on left side and only 1 on the right side. In order to balance, we can add a 2 before MgO on the right side. Now oxygen is balanced on both the sides. But what about magnesium? On the right side, we have 2 magnesium. On the left side, we have only 1. This time, we can add a 2 before magnesium also. And so we get the balanced chemical equation as 2Mg plus O2 gives 2MgO. The correct formula of aluminum hydroxide is, which one should be the correct formula? When we studied the appropriate use of bracket, we understand that Al bracket OH thrice is the correct formula of aluminum hydroxide. Match the pairs. Copper sulfate reacts with zinc to give zinc sulfate, copper and heat. We can see that zinc is displacing copper over here. Such type of reactions are displacement reactions. Second, calcium carbonate breaks down to form calcium oxide and carbon dioxide. One reactant breaking down into 2 products. Such type of reaction is called decomposition reaction. Calcium oxide reacts with water to give calcium hydroxide. Opposite to the previous one, here 2 reactants are combining and making 1 product. So obviously it is a combination reaction. If you see the 4th reaction, we can clearly see that the reactants are exchanging their ions. So this reaction should be a double displacement reaction. When zinc metal is dipped in copper sulfate solution, what will happen? The solution becomes colorless and reddish brown copper metal gets deposited. We get this with the help of reactivity series. We know that zinc is more reactive than copper, so zinc will displace copper from its solution. Study the following chemical reaction and answer the questions given below. Copper oxide react with hydrogen to give copper and water. Identify and write the name of substance getting oxidized. Who is getting oxidized? We know that hydrogen is gaining oxygen, so hydrogen is getting oxidized. Write the name of oxidizing agent. The one which undergoes reduction is actually the oxidizing agent. Copper oxide undergoes reduction, so copper oxide has to be the oxidizing agent. Write the name given to the above reactions. It is redox reaction since oxidation and reduction is taking place simultaneously. With this, we have completed the discussion of the entire chapter. I hope you have understood concepts which I have covered in the video. If you find this video useful to you, then do like, share, and subscribe to our channel, because of which you will be able to get all episodes of this series on our channel. Also, in case of any doubts or queries about any concept or topic, feel free to leave a comment in our comment box and we assure to solve your doubts. Be confident, achieve glory. Thank you.